Till now we have seen that the KNN is a deterministic algorithms. Actually, we have, if you just taken the our two class classifications, if you just taken the two class classification, in such two kinds class classifications, what are actual output level? We are in general considering 0 or 1, or anyone, if anyone can consider -1, 1. So let's take our output level is 0 and 1. So in such cases we have seen that we have concluded our output will be a class 0 or it will be class 1. Means what? Actually it is a deterministic algorithm. Yes, deterministic algorithms. We are not sure the our class levels about the, it's, I'm just taking our class level is 0 or 1, so we are not giving the conclusions about how much sure about our class levels. So let's see how to improve this thing to deterministic to probabilistic algorithms, or to some assume some we have given some conclusions of our output level, how much confidence, how much certain about our output levels. So let's see how this thing will be happens. Suppose I'm just drawing a pictures, I through a pictures I think it will be more visualizable. Suppose let's take, I have some class level like that. Suppose this is some negative points, and here we have some positive points. This is one set of data, and let's take, we have another set of data like this, like this, like this. Okay, so this is one cluster of data, and this is another cluster of data, and the in each cluster our number of points is equal, 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Here also we have 1 2 3 4 5 6 7 8. Okay, so suppose let's take, we have consider a query point here, we have considered a query point here in this cluster. Okay, query point. So in this cluster, if we consider the 7NN, suppose let's take in this cluster we am considering the 7NN algorithm. I'm choosing here k is equals to 7. So in such scenario, we what are the if we just taken in KNN algorithms, what will be the output of this KNN? So this output here we have 5 rate points, means 5 negative points. Here we have 5 negative points and 3 positive points. 3 positive points. So these are the positive points, and these are the negative points. Okay, so in such case, how, so if we just taken the majority vote sample, what we have decided, if we just taken the majority vote for this query point, majority vote, according to this majority vote we have decided that our negative point is, number of negative point is 5 and number of positive point is 3. So the majority vote, according to the majority vote, according to the majority vote, we can conclude that our YQ for this XQ will be what? Will be negative. We can conclude by simple, we can easily conclude that it is negative. But here suppose let's take our query point is in this region. Suppose let's take here XQ is in this regions. So in this region, if we take the same 7NN, if we take the sample 7NN in these regions, if we take, then what will be the XQ? So in these regions our XQ will be look like that. Here we have, out of 8 points, we have H points is negative, 4 5 6 7 8. H point is here, H point is negative, and we have no, here we have no positive points. Here our number of positive points is 0. Here we have 8 of negative points and number of positive points is 0. So what will be the, if we just taken the same majority vote here, what will be the output? So in such cases our output will be also negative. In such cases also output will be also negative, give the negative. But the main thing is that here we have more certain, because our every point is here negative. But in this, just you see these regions, but in these regions we have less certain, because here we have less number of points are negative. So in these regions we have more certain, we have in these regions we have more certains of our negativity of our this output level, of our output level of this query point, we are more certain. But in these regions we are less certain. In this region we are less certain. So to how to numerically quantify these things, we have to take just telling this is the most certain, I am 100% certain, I am not so sure. How to numerically quantify these things about our class levels. So let's see. So just I am taking the same examples here. Just I am taking the here 7knn 7nn I am taking here, and I am just same example I am considering. So here xq in our query point is here for 5 first in the first regions. If I just consider the first regions, here I am just it is naming this is the first region, this is the region 2, this is the regions R, and this is the region 2. If we just consider the regions R first regions, then here negative points is what? Negative points is 5 negative points, and positive point is what? 3 positive points. Here 3 positive points. And on the basis of the majority vote, on the basis of the majority vote, what we have concluded? We have concluded that our OIQ will be negative by simply using the majority vote. But and here if you just rename this, it is just take this point as xq dash. I think this then it will be better to identify. So in R2 regions, if we consider the xq dash, then out of 8 point, our out of 8 point is 8 is negative and 0 point is positive. And also if you just consider the majority vote, I am taken the same conclusions. This our output of this query point xq dash as is also negative. But here we have more certain. Here we have more certain, here we have less certain. Okay, now quantify this uncertainty. Just just see this thing. This is the quantify the uncertainties. So to quantify the uncertainty, now how we'll do that? Just simple using the primary, the probability concept. Now to quantify this uncertainty, how we will quantify? So suppose if you just consider the region 1 cases, just I am using the white color for regions 1. If you just consider the regions 1 cases, so here if you just count the probability of the output level, it will be the probability of it will be negative classes. Negative classes what? We have total how much point? We have total 8 point, and in this 8 point how much negative point? We have 5 negative points. So this probability will be the number of negative points plus divided by number of total points, this point. And for R2, this value will be the gas total. Out of 8 point, 8 point is negative. So here this value will be 100%. Okay, but here not, we cannot say this value will be what? This value we have suppose let's take 5 by 8 means near about 50 by 8 near about 60%. Near about 60% of this value is this regions 1 negative value. So we have seen that for the regions 1 we have more less certain, because we have get the our certainty about 60%. We am about sure the our class level will be negative, we have sure about the 60%. But here we have more certain, perfectly means 100% sure our class levels will be negative. So this thing, this concept of the certainty, how much certain we have about our class levels, this in machine learning, in the actual real practical of the machine learning, this thing will be very applicable. Just we am saying that our class level will be negative, but I am not saying how much certain about our class levels. If we just taken this kind of if we just taken this kind of confusions degree, how much certainty degree in our calculation, this thing will be more useful for practical purpose, for application purpose. So similarly, for the same things, we can easily calculate for this R1. So for R1, if we just conclude, if we just interest to calculate it, the positive class, how much certain about our positive class, this will be mainly, so what, this will be 3/8 simple. And the same thing for also, for the same thing also for applicable for probability of Q test will be positive, the same thing, but this will be 0%. So this will be 3.8 means what, 3 means near about 40%, near about 40%. So the probabilistic, in probabilistic class levels, we have to quantify our degree of certainty. We have not just not saying this point will be this class or this class. Also we have given some degree about our confidence, about our certainty, how much certain of our class levels. This is not for applicable for classifications algorithm, this is also applicable for regressions, as well as when we are learning the deep learning method, when we are learning the unsupervised model. So this thing, this probability concept, the certainty level of probability concept is always applicable, and is in real world, this is very useful. Okay, I think that the simple concept is understand, we will easily understand how this thing is important. The main motto of this lecture is to understand the just instead of saying that our class level, just instead of saying our class level class 2 or class 3, it will be class this or this, instead of saying this, I am using this degree of confidence, how much confidence about our result, and how to certain of our class levels is. This thing will be very useful in practical world, in the industrial world, in the practical real world. Okay.